Hello students, in today's session we are going to discuss correlation test of normality that we apply or use to test if the given data are approximately normally distributed. We call it correlation test of normality due to the fact that we are going to observe a relationship between our data values and the normal scores that we are given in this table as per the number of observations. Now, we are first going to structure or construct or make amendment in the formula for coefficient of correlation. And for this, what I'm doing, I'm writing down the formula for the coefficient of correlation. In the numerator, we take the covariance of x and y divided by the square root of the variance of x and square root of variance of y that can be alternatively referred as standard deviations of x and y respectively. What we can do here, we can take out n common from the numerator as well as from the denominator like this. Here, from this first factor, which is the standard deviation of x, we also take this n common out, and consequently it will become the divisor of the second factor. Similarly, square root of n summation y squared and minus summation y whole squared divided by n. So these two n factors inside the square root, when we multiply these two together, we get n, and this n will be cancelled out from with the n that is common taken common out in the numerator. Now, what we can do, we can write down this formula again in this way. In case of correlation test of normality, we are establishing a connection or correlation between our data values and the normal scores. And the normal scores we denote as W, and we need to look at the property of normal scores. It is reflecting from each column whatever the number of observations are. When we take the sum of normal scores, we get 0 as a sum. And over here, we can write down our formula alternatively in this form. So instead of y, we write down w, Here as well, summation W divided by N, summation x squared minus 1 upon N times summation x whole square, summation W squared minus 1 upon N times summation W whole square. Since summation W is equal to 0, that is the sum of normal scores, therefore this entire term or factor will become 0, and this entire term or factor will also become 0. And we end up with the formula as summation Wx divided by, this can be written as Sxx times summation W square, what we are left in the second factor in the denominator. So this is what the formula that we use in case of correlation test of normality. Now I'm taking an example or the data on my own, and let's assume that we are asked to test the hypothesis that marks of students are not normally distributed. So this testing statement, we give room in the alternative hypothesis. So marks of students are not normally distributed, and as a statement contradictory to the one that we have written down in alternative hypothesis, we write down or state it as marks of students are normally distributed. And let's suppose we are asked to perform this test at 5% significance level. So we denote or mention it in this type of level of significance. This test is always a left tail test for a reason. Because in case of testing correlation or in case of testing normality of the data, we are supposed to first arrange our data in ascending order. And since normal scores are also arranged in ascending order, therefore, this is a special case of correlation that lies between 0 and 1. So coefficient of correlation lies between 0 and 1 in this particular application. It's not from -1 to +1, because when the two variables are arranged in ascending order, this is the possibility to get a positive correlation. Now I'm mentioning this test statistic, what we have just derived in the previous slide. Now to obtain critical region, let's assume that the number of observations I'm going to give you in the data are 12. This is how we write down or we draw the sketch of the curve. This is a negatively skewed distribution. If we refer the table that gives us the critical value for correlation test of normality, so we get 0.917 as the left tail critical value. That gives us the rejection region for H naught here and the non-rejection region for H naught. And it is understood that when we have a coefficient of correlation value closer to 1, it does imply that our data values have a very strong relationship with the normal scores, and we will draw a conclusion in that case that the data are following normal distribution. If we observe a weak correlation, alternatively, then it is falling in the rejection region, and weak correlation will indicate that the data do not follow normal distribution or are not normally distributed. So weak correlation we observe in the left tail, strong correlation we observe closer to 1. That's why it is always a left tail test. So we stage our rejection criterion as H naught would be rejected if our rho calculated is less than 0.917. Now I am giving you data, and deliberately I am giving you the data arranged in ascending order already. So let's suppose these are the marks of 12 students out of 60. 20, 22, 25, 28, 30, 32, 37, 40, 42, 45, 47, and 52. So these are the marks of 12 students. Now what we do, we will copy over here normal scores from 12th column, minus 1.64 and minus 1.11. Then we have minus 0.79, minus 0.53, minus 0.79, minus 0.53, and minus 0.31. Then minus 0.10, and the rest of the values would be symmetrically distributed. What we need to do now, I'm going to enter this data in the calculator. Using regression mode with linear option, and if you have another calculator or different calculator in which we go for a plus bx option in regression, so you can follow accordingly. And in that calculator, the tabular structure will appear. You will have 2 columns, one for x, another for y, and the column for y is in fact your W scores. So I'm right now entering the data in my calculator, and you can do the same thing. And then we will directly get the sum in this way that we need to have for data analysis or for making substitution in the formula. So the very first thing, that is summation x squared. Summation x squared equals 15,888. Summation x we get as 420. Summation y squared, which is summation w squared in our case, it's 9.8656. Summation y should be 0, and summation xy in our calculator will give us summation x times w. That's 107. Summation x times y, what our calculator is representing, is in fact summation x times w, and the value is 107.05. Now what we do, we need to first work out the value of sxx. Sxx equals summation x squared minus 1 upon n times summation x whole squared. So that's 15,888 take away 1 upon 12 times 420 squared. 15,888 minus 420 squared divided by 12 gives us 1188 as the value of sxx. Now we make a substitution in the formula to get the test statistic computed. That's sorry, that's summation xw we need to substitute in the numerator, in fact, and summation xw we have worked out as 107.05 divided by, inside the square root, we have 1188 that we have worked out as sxx, and the value of summation y square, which is summation w square, in fact, that's 9.8656. No, so now dividing These two factors, we get our answer as 0.9888. And since our rho calculated is greater than the critical value of 0.917, therefore H naught is not rejected. We do not reject H naught is our decision. We need to make a correction in the conclusion. This is not the case of rejection. Uh, the test results are not statistically significant at the 0.05 significance level, and data do not provide sufficient evidence to conclude that marks of students are not normally distributed. It does not favor that argument. So, in fact, marks of students are normally distributed is the outcome. That's all for this session.